हेलो गाइस, तो कैसे हैं आप सब। आई होप आप सब बढ़िया होंगे। मैं भी एकदम बढ़िया हूँ। सो लेट्स स्टार्ट टुडेस Vprople question of the day. So the name of this question is count beeps. So basically in this question we have been given a binary string and we have been told that we have to rotate this binary string in anti-clockwise direction the number of times the length of the string, and the anti-clockwise rotation occurs in such a way that the last element comes to first the last element comes to first, and the remaining elements from the first element till the last will adjust accordingly. Like here we have been given a binary string, so after one rotation its last element, that is 1, will come to the first, and the remaining elements from the start will adjust accordingly after the first element. Okay, so we have to do this rotation the number of times, the length of the string, and after each and every rotation we have to find the binary string's decimal equivalent, and then we have to check if its decimal equivalent is even or odd, and at the end we have to print the number of decimal equivalent that were even. So basically in this question we have been given a binary string and we have to rotate this binary string the number of times the length of the string, and after that we have to find its decimal equivalent, and after finding its decimal equivalent we have to check that if its decimal equivalent is even or it is odd, and at the end we have to print the number of decimal equivalent that were even. So there are two ways to solve this question. First of all, taking the string as input, initializing a counter with 0, running a for loop the number of times the length of the string, and in each for loop updating the value of string by rotating it in clockwise direction. After rotating the string in clockwise direction, convert it to its decimal equivalent. Check if the decimal equivalent is even or not. If it is even, then add +1 to the counter, and at the end of the for loop print the counter. So this was a lengthy way to solve this question, and most of the responses that we got are containing the same logic and same code. But what if I tell you that this question can be solved in just one line of code? If you have a good knowledge or just a basic knowledge, if you have just a basic knowledge of how binary strings get converted to their decimal equivalent. So if you don't know that how binary strings get converted to their decimal equivalent, let me show you. If you have a binary string with 1010, then the way it get converted to its decimal equivalent is we take the first element of the list and multiply it to the 2 to the power the length of the list minus this element's index value. So this element index value is 1, and the 0 has index value 2, and 1 has index value 3, and this element has index value 4. So the way to convert the binary string to its decimal equivalent is to multiply its corresponding elements to 2 to the power the length of the string minus the element's position value, and then sum all these things. uh, First of all, multiply 1 with 2 to the power length of the list minus its position value, that is 1, to 4 minus 1 3. After then do the same task with 0. After then do the same task with 1, and the same with 0. So we can see that in all these three elements, even if it is 111 or 101, all these will be the multiple of 2. Even if we sum the value of these three elements that we have found here, that is 1 into 2 to the power 3 will be 8. It will be 0 as it is multiplied to 0, and this 1 into 2 to the power 1 will be 2. So even if we add these three elements sum, 8 plus 0 plus 2, it will be 10. So it is multiple of 2 in any case. Whatever be these three elements, it will be a multiple of 2. But the last deciding factor that decides that the decimal equivalent will be even or odd is the last element of the binary string. If it is 1, then 1 into 2 to the power 0 will be 1, and if it is 0, then 0 into 2 to the power 0 will be 0, and if it is 1, then the decimal equivalent will be odd, and if the last element is 0, then the decimal equivalent will be even. So what we have to check here, that after each and every rotation, even if we check that after each and every rotation, if the last index is 0, then it will be an even equivalent, and if it is not 0, if it is 1, then it will be an odd equivalent. So why not I count the number of zeros, because after each and every rotation there will be 1 or 0 at the last index. either it will be 1 or 0 at the last position. So why not, if I count the number of zeros present in the string, then I will get the number of decimal equivalent that will be produced after rotating the string the number of times the length of the string. So you might have not got me the way I want to teach you. The way I want to tell you is, the last element of the binary string decides that the binary string decimal equivalent is going to be odd or even. If it is 0 at the last element, then it is going to be an even string, then it is going to be a even equivalent. And if it is 1 at the last place, then it will be a odd equivalent. So the best way to check that the binary string equivalent decimal equivalent will be even or odd is to check that if its last element is 0, because after each and every rotation there will be something at the last. If it is 0, then its decimal equivalent will be even. So if I count the number of zeros present in this original binary string, then it will give me the number of even decimal equivalent that can be produced after rotating the string the number of times the length of the string. What I'm trying to tell you that is, if I rotate this string the number of times the length of the string, then there will be something at the last position. If it is 1, then its decimal equivalent is going to be odd, and if it is 0, then its decimal equivalent is going to be even. So straightforward. If I count the number of zeros present in the string only, then I will get the number of decimal equivalent which are going to be even. So if I write here print input string dot count, count 0. So whatever be the input string, just count the number of zeros and print the number of zeros that are present in the input string. So just for your knowledge to say that that the code is working, let me first give a false input, false code, and after that now let me write input, the one line code, input dot count, count. And what are you going to count? You have to count the number of zeros that are going to give me the number of decimal equivalent. So let's check the code if it is correct. Yeah, so this is the correct code, and this is the shortest possible code ever, that because the shortest possible code can be only present in one line, and this code is also a one line code. So this was the shortest code possible for this particular question. So let me explain you once again what I did in this question is, I counted the number of zeros present in this string, because if because after every rotation there will be something present at the last index, last position. If it is 1, then its decimal equivalent is going to be odd, and if it is 0, then its decimal equivalent is going to be even. So even if I count the number of zeros present in the string, that I will get after each and every rotation, so I will get the number of even decimal equivalent that I want to find in this question. So this was the potential and the most shortest possible code for this question. I hope you must have liked the solution, the way I explained you the most shortest possible code ever for this solution. So go and hit the like button and subscribe the channel if you're new to this channel, to appreciate my efforts, because I nearly spent 20 minutes just to observe the question and to write the most shortest and efficient code possible. So I would also like to congratulate CS Aditya, L Aditya Raj, Pranav Balaji, Ankush Jha, Muralidharan V and Rishu Singh for successfully passing all the test cases and sharing the code with us. Congratulations guys, because you have completely passed all the test cases. So this was all for today. Thank you. Have a nice day.